Round 2. Fight!
Welcome back to my YouTube channel, bruh. It's part two, so shout out. I'm a bit tired of being working on these notes. I hope you do enjoy today's session. It's a pretty chill one. Yeah, I ain't been up too much. I took a little walk today, took a little breather, just trying to clear my mind for the exams. And yeah, let's dig into it. So, like, the previous point that we covered was understanding adjacency, because, like, adjacency is the point at which we start constructing the graphs and everything that we are trying to implement with the algorithms. Primarily working with traversal currently because it's like we're trying to get from point A to point B, so we shall see how we do that. Hey man, I'm getting better at this YouTube thing. It's because I talk too much, bro. But anyway, so I'm like understanding adjacency is the concept of encapsulating the functionalities that we can perform on a graph, as adjacency leads us to then visualize or have a representation of the graph, not just um like visually, but more in code. So we are able to create matrices and plot points of a graph on those matrices. But yeah, so we have the adjacency list. Yeah, list adjacency list and the adjacency matrix. We define adjacency as when two vertices share a common edge. So it's like we have to go back to the why am I forgetting this? We have to go back to the Königsberg Bridge problem where it's like we're trying to get from point A to point B through the paths that we take. And by understanding adjacency is by understanding that there's an edge between two vertices. So we are trying to go from one vertex to another using that edge as the pathway. So adjacency in itself is defined as where this is the adjacency list itself. It's like this is how it would look. So wherever a vertex is connected with another vertex, that means there's an edge in between those 2 points. So that's how we define adjacency. And once we understand that, right, we're then able to jump into the code, because today is all about coding. Today is all about, breaking down how we get to this point. So I'm like, how would we go about constructing the graph in code? And I'm sure you can like see on my PC. Like the thing is, I'm currently recording and I'm watching the live, but on the UI of the software I'm using, it's kind of like there's a graph thing that I constructed. So that's what I want to get to. It's like understanding how not only we would output this as like your code, but like how I went about putting a more tangible feeling to the algorithm rather than just saying these are my edges in the vertices, give me the output. No, I wanted it to be more interesting. So this is what we got. I'm gonna get to it. You gotta relax for that one. Cause it's pretty cool. It's pretty cool. So relax. But anyway, we jump back in. So I made a couple points here. So I'm like, we have to keep in mind that with the concepts that we learn in this topic, data structures and algorithms, we have to implement all the concepts and visual representations as of graphs as code. So this is a more untraditional way of doing it, because we would usually have to plot the ones and zeros, and whenever there's a one on the matrix, it's like we're using boolean variables to say, okay, there is an edge in the square, so that means the condition is true. And then I'm like, understanding adjacency matrix. We have to use the concepts of adjacency matrices as a means of expressing the graphing code. Adjacency matrices would be constructed as a two-dimensional array that represents ones and zeros, but like we can just think of this as like a chessboard. Like that's the best way for me to put it for y'all. So adjacency matrices are based on the concept that we have a pair of vertices that share the same edge. That path I've been talking about, that wherever there's a path in between, we know that they are connected. So we will put a 1 in that space to say, okay, there is an edge that occurs between these two vertices. It's not bad, is it? It's not bad. And then I'm like, part two is identifying the components of a graph. So with the graph, we take note that we are storing a set of values that either represent a vertex or an edge. And I think I made not a mistake, but I have more clarity on saying we are representing the edges that are on those vertices. So we jump in and we import the utility package because we finna get to that. And then I just name my class graphs, right? And then I create a method, a static method. That means I can call it with the class name and the method itself, the method identifier. But since it's within one code block, right, I can just call the method name. I don't even have to go about saying yada 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 is equal to yada yada yada. If you get what I'm saying, it's a little Java joke. Not funny. But anyway, it's like we just create an integer matrix, right? So here I say public static void add edge, which tells you what the method is doing. We are adding the edges to the graph, and two-dimensional arrays are rows and columns. So it's like whenever we plot a 1 in the space, it's like in two-dimensional space, there is like a dot. Going back to this graph thing, I literally can't see it, but like this right here is what we're aiming for. And then I just say integer I and integer j. Whenever you're working with variables such as I and j, it usually means we are pointing to a place. We usually refer to them as pointers, not even necessarily in memory, but just pointers to a specific place in a data structure. So maybe you would consider it like memory, but that's not important right now. And then I say here public static void display matrix, and this only takes in a two-dimensional matrix as a parameter. So when understanding data structures and algorithms, my biggest take is whenever you're looking at code, make it sound like English, bro. Like I cannot stress it enough. It opens your mind to like, dude, this is doing this. Even though it's like you confused as hell, but you continue to build on the understanding of understanding code components and just wording it. So I'm like, public static void display matrix takes in a two-dimensional array called matrix, right? And then this first for loop is saying for each of the rows within the matrix. That's why we're using this colon here, because the colon operator is saying for every row in the matrix. So it's literally int I is equal to 0. I should be less than the total length of matrix I plus plus shortened into that, which is pretty cool. And then we just go into the next one. So like there's another layer where it's like for all the values in the rows, we are printing out the value. As simple as that. We are just saying visit every box in this chessboard and print out all the pieces row by row by row. So places that don't have pieces would be 0, and places that do have 1. That's another way of painting that picture. And then we just print like a empty thingy just to have space and stuff like that. But that's how you construct a graph using an adjacency matrix, everybody. Shout out to that. It's pretty cool. It's interesting. So we just go into our public static void main, where we set the number of vertices to 4. This is represented by an integer variable. And then we create our adjacency matrix equal to those vertices that we have set. V goes in here. I don't know, it looks kind of different. One is capitalized. Hey, you'll see it in your compiler. But anyway, I just say add edge. We're adding the edges to each of the spaces in the matrix. That's how we're performing this. And then once I do all of that, I just say system out print line, displaying the adjacency matrix, and then we print out whatever was happening in our adjacency matrix. And shout out to that. Excuse me. And then now, since we are covering the concept of how to depict graphs, right? So another way of doing this is with an adjacency list. So adjacency lists work on the basis that for each of the vertices that we have, right, I can say vertex 0, print out all the edges. So 1, 2, 3, 4, 5. Vertex 1 has these edges 1, 2, 3, so on and so on and so on and so on. So I'm like, to display the graph, we use an array of lists to store the edges that occur between the pair of vertices, going back to adjacency, going back to Königsberg Bridge problem, going back to Leonard Euler. I hope you watched the first one because that's how we got over here. So we have to set the size of the array equal to the number of vertices that are present in a graph. Makes sense. So we jump in to our class called graph adjacency list, and then here I create a method, learning how to read it like English. So I'm like public static void. This is a method that this is a method that we set values in, because any void method means we are setting values in it, and these are the parameters that we want to set. So I just call it add edge. And then when you look at those like little angle bracket thingies, it's like keep in mind that we are passing certain data types to our storage known as the list. So we're saying in this list, walk with me. In this list, we have a list of integers. That's how we're doing it. So in this list, right, we are storing lists of integers, and it's a pretty clutch method if you know what you're doing, because it's like if you work with languages like Python, it's almost like trying to explain to someone working with a dictionary of dictionaries. It's easier to explain in that language because I feel like it's just more natural to it. But in Java, it's like, ooh, there's a little bit of, yeah. But anyway, jump into the iteration. So here I'm just like normal for loop. We set the condition to be less than the length of our adjacency list, and then normal iteration. So we system out print line all the values that are in our adjacency list, right? And then we print that out. So that would be your vertex that you're currently on. And then for the edges that are on incident with that vertex, back to the first video, we will then print out all those edges next to the value of the vertex. So it's like for j in the adjacency list dot get. So how I could explain this is like for every value that our vertex has, for every edge that our vertex has, print out all those edges. Because here when we call get, right, we're just saying for that vertex get all the endpoints. Pardon me. But yeah, man, and then we just print out all the edges. Cool. And then we go back into our public static void main. And then I'm like, I set vertices of 10. And keep in mind, with adjacency, well, in this case, I think it's different because adjacency matrix would be like a box. The way I could then define this one is like working with a linked list, because you're connecting the current node. I would say that in this case, like you have to think about the vertex as the head node, right? But anyway, you take that node and connect each and every instance or each and every edge to that head node. Walk with me, because I don't think that's how you do it, but trust me on that. And then we just iterate through. Wait, pause. So yeah, we construct our integer vertex of 10, and then I construct that list that contains integers equal to new array list, and then I pass my vertices into the data structure. And then I'm like normal like all the for loops is gonna say either normal, or I'll break down the condition if it's not as simple as it gets, right? So I'm like, for integer I is equal to 0, I should be less than vertices I plus plus standard procedure, and then I'm just adding all the values to the array list, all the yeah. Yeah, and then I just add the edges, and then from that point on I just call the adjacency matrix method that just iterates through the edges connected to that one vertex. Sorry, man, it's a big topic. I'm gonna call it here because I said it's a 3-part series, right? And then I don't know if I should, like as I said with my previous videos, I hope you've been subscribing to the channel, liking, commenting, sharing, hopefully. because not a lot of us are studying IT, but those who do, shout this out to your friends, please. It's like all this is very condensed in a sense. You could go deeper, but like for me, I'd rather sit here with you and read it to you and break it down with you in real time. Because I was thinking about it's a three-part series, but do I just base it on graphs alone? Or do I implement a little bit of trees for that? That was a bar. I'm sorry. That was a bar. Do a little bit. Nah, okay, cool. But anyway, I'm just saying, like, I can move on to the next part, but I'm just gonna cut it here. I don't want to waste your time. I appreciate your support, and it was a great session. Because the really only the next part that we need for the exams and just life after this is the traversals. So now I'm gonna share my little secret, this program that has been on the screen. Right. So I created a program where we have an instance of a graph that I am running algorithms on. So I say create a graph, right? You would think this is the graph we created, but I run the algorithm. And based on the functioning of the adjacency matrix, all I really did, matter of fact, was let me go to it, show you what's popping. Um, yeah. So we have a bunch of methods that we've already seen, right? The adding the edges to the matrix, displaying the matrix, and just iterating through those values. So now I'm constructing what is known as the random class, right? Because the random class just allows us to create random ass variables. Ooh, I don't want to swear, but random variables and place them in our adjacency matrix, which I think is cool as hell. Because I was like, oh, this is sick. I was thinking about it. I think on my way home, like yesterday or the day before, I was like, this is the way it should be taught. You feel me? Because when you make a program like this, it was like, oh, scratching my brain. It was a wild time. But anyway, so what I do, I just construct the random what you call the object that generates random values. It could be any data type, right? And then I say int of vertices, right, is maximum of my adjacency matrix dot length. So whatever grid that I draw, I want to make sure that it is the entire length of that grid. That's what I'm trying to say there. And then I'm like adding the number of random edges. We can then add according to the length of the edges we have set in the method declaration. So I just jump in here and I say for loop integer I is equal to 0. I should be less than the number of edges that we are passing in. So we are making sure that there's no overflow of edges. Like even if all the vertices were full, we are not able to then say add one more. Not even the vertices, the edges, because the edges are all these squares that are on the program. I'll run that for you again. And then I'm like, while vertex 1 and vertex 2 are equal, making sure that we don't have an overflow error. If we had an additional vertex, it's like you break in your program. Or the adjacency matrix is equal. Like we just, in this case, we're just making sure everything stays equal. And then we assign those values to the vertex 1, vertex 2, and then we add them to our edges. Yay, beautiful. And then I come back and then I was like, ooh, look at me. I was like, run algorithm. So yeah, this just creates a random instance of a graph, right? And then I'm like, takes the shortest path. Then I run the algorithm. And then in this instance, it's like it plots the shortest path between the 2 points. But I need to debug it because at this current moment, I'm not happy with it. I want to change the ability to see the entire part as yellow. I want the whole thing to be yellow. But as you can see, if I was to like chart this as a graph, a more traditional like line graph or something, you would see that this is linear. Like, yeah, that's the best way I could explain it. But let me not get lost in my little sauce, bro. Like, tight shit. Let me not swear. Sorry, but yeah, man, super tight. Happy about it. Gonna make another one with the trees and ooh, juicy. But that's your boy signing out.